they're pretty easily to manage even when large within Excel. As far as free tools, I am not currently aware of any free test design tools. That there certainly might be some out there. So, I would say a web search for free test design tool might turn up something useful. I mean, there are some special purpose test design tools that are free. For example, if you go to pairwise.org, you can find free pairwise testing tools, but that's not a general purpose one. Okay, let's see. Yeah, Alexander continues his comment that he has seen use cases and decision tables used together, and again, I'd encourage you to do that, to try to write the article. See, Ken has a comment here. Is there not a risk to collapsing cases that, although the business logic dictates the same action, the implementation has a defect on the condition indicated as do not care? Okay, Ken, that is a good point. Yeah. I mean, when you look at this and you look at a column or a pair of columns and you say, this condition simply can't happen. As we saw with some of the combinations in the example, you could say, well, it's just impossible and it's nonsensical. So, imagine if you're testing an ATM, I mean, one of the conditions you would look at is whether the card is valid, and then the other thing you would look at would be, whether the PIN is valid. Well, the card is not valid. In other words, it's something like a driver's license or some other kind of card, or a card without any magnetic stripe at all. And it's just simply impossible for the PIN to be valid. Now, of course, it is possible that inside the code there's a Boolean condition that gets misset to say that you're dealing with a card which is invalid but a PIN which is valid, and I suppose that you could look at those nonsense combinations of conditions and try to figure out a way to force them to happen. But it's quite likely that the user interface is going to prevent you from creating those conditions, at least at the UI. So if you're testing at the code level, sure, maybe you can force that to occur. But if you're testing at the user interface, while you could, I suppose, try to create some of those combinations, then in many cases they're going to prove impossible. Now, you definitely, you have to be careful with the "oh, that can't happen" response that you get from requirements engineers, business analysts, and programmers sometimes. Yeah, part of the role of testing is verifying that which can't happen indeed can't happen. So, I would say you've got a good point here, and I think when collapsing a decision table, one should err on the side of caution. In other words, if in doubt whether a given pair of columns are actually a useful pair of tests to run separately, and keep them separate rather than say, oh well, that can't happen, and collapse them together. So good point, Ken. Thanks for bringing that up. Let's see. Pavel says, "Thank you very much. You are quite welcome." Comment from 80 with a question. Just read your critical testing processes book. It's great. Thank you for saying so, 80. It's certainly a book I enjoyed writing. It was quite a job to write. It was a very complicated thing, and I wish more people had read it, because it's of the books that I've written, it's probably one of the ones I've worked the hardest on and the fewest people have read. But I'm glad that you like it, and it certainly hope provides good ideas to you. Now, your follow-on here, failure mode and effect analysis seems a good way to start testing. How does it link to decision tables? Well, so let's pop this up to the higher level. Failure mode and effect analysis is a particular technique for doing risk analysis, and in risk-based testing, what we are going to do is we are going to identify quality risks, bad things that could happen that would cause the program to not have the level of quality we want, and then use the level of risk to decide how much testing we should do for those. So the link there would be, let's say that we've identified a particular risk item, which is credit card processing is incorrect, okay, for an e-commerce site. Now that relates to the decision table that we just looked at. Now if we say the risk is very high, then maybe in that case, you know, following on to Ken's comment, we don't actually collapse the decision table, where we try to force every one of the 16 possible combinations of conditions that we saw occur, and we do apply the equivalence partitioning that I showed, which was expanded the number of tests for one column up to 7, and we apply the boundary value analysis I showed, which added yet another test. So we could be looking at 22, 23 so tests from that decision table, and maybe even more. Now, if we say that the risk associated with that is very low, then what we would be doing actually is we would collapse, and maybe we wouldn't do boundary value analysis. We wouldn't do equivalence partitioning. We'd say, you know, 7 tests is enough for this, right? Or maybe even less. Maybe if some of the conditions there, we'd say, yeah, it's just not that big of a deal. So risk in risk-based testing is used to make a decision about whether one uses the techniques expansively to try to generate as many tests as possible, or whether you use it sort of conservatively and generate limited number of tests. Let's see. A comment here from Mark. I've been on a project where the decision tables got big. We split them by common points of decisions and linked tables in a physical flow. So that would seem to make sense. Yeah, if we could say, okay, well, we make this set of decisions first, and then this set, and then this set, then that would certainly be one way of partitioning it. For example, if we have an e-commerce system where we go through a sequence of 3 screens to check out, then you, instead of putting all of the conditions associated with all 3 screens on a single decision table, you could have 3 decision tables and look at them. And then, of course, you could make the assumption that the precondition of getting to the second decision table was that you had already handled everything on the first, because you had to click next and get past that first screen to get to the second screen. And similarly for the third screen, that would mean that the first and second screens were handled, and so those conditions and actions were out of the way, which I would expect would trim the size of the decision table quite a bit. So thank you for that, Mark. Let's see, other questions here. A comment from Alexander says, already written a number of years ago for BPM. It looked at use case in BPM as flow and decision tables as business rules. So I guess you're saying that the article's already been written. That may very well be true, but that doesn't preclude a new interpretation of it written by you, perhaps based on your experience of using it on a real project. And that, to my mind, is always great when you can have a article that's written on application of some technique, which perhaps is already well described in theory, the application of that technique on real projects. So I, again, encourage you to think about writing such an article. It could be very